today is to condense logs, and before we do that we have one more expansion to look at. This one is log base 2 of 3x to the second y to the fourth over 2z to the third w to the sixth. So this is a division, which means eventually we're going to end up with subtraction in there somewhere. But that somewhere is the whole purpose of this problem. Here's what you must do first. If you want to break this up as subtraction, you got to write it as log base 2 of 3x squared y to the fourth, and then minus log base 2 of 2z to the third w to the sixth. Notice I put parentheses around the quantity that's next to the log. Now you have to break up each one, and on the first one it's pretty simple. You're going to end up with a log base 2 of 3, and then plus 2 log base 2 of x, and plus 4 log base 2 of y. But when you get to the minus sign, this is where you could possibly make a mistake. Most mistakes are made in this type of problem on the back end. Remember, this is minus this quantity. So you need to think of it like this. Whatever you expand out here has got to be inside of a set of parentheses, such that when you're finished with it, you distribute this all the way through. So in other words, even when you expand this out, you do have pluses, but this will make them all minus. So that's the one thing to remember. So we'll shift over to here and finish this out. If I go like this, and it'll be quite a bit of writing on this, but it's worth doing, minus the quantity of log base 2 of 2, and then plus 3 log base 2 of z, and then we will have plus 6 log base 2 of w. So we have this entire line there on the bottom. And now notice that when you have this, you have to distribute it all the way through. So every one of those become minus. It's not just minus this first one and then plus plus. It's minus all of them. So if we write this out, we would have, so you need a marker, log base 2 of 3 plus 2 log base 2 of x plus 4 log base 2 of y, and now distribute the minus sign, minus log base 2 of 2 minus 3 log base 2 of z, and then minus 6 log base 2 of w. So that's the only other thing we need to look at from yesterday. So you have 2 log base 6 of u minus 8 log base 6 of v. We tried some of these yesterday during the bonus problems, and a few of you got these right. So if we're going to go backwards, we know that the log is base 6. If this is base 6 and this one were, say, base 4, it's not going to work out. They have to have the same base. So pay attention to that. Some problems on a test might just be you can't condense them because the bases are different. On the top, you're going to have a u, and the u is going to be to the second power. That comes from this going back to where it belonged. And then on the bottom, you'll have a v to the 8th power, and it's that 8 going back to where it belongs. So this is it. 8 log base 5 of A plus 2 log base 5 of B. This is addition, which means it's a multiplication problem. The bases are the same. You have 5. So you can do log base 5. And since it's addition, it means it's the result of a product. So you have A and B that are multiplied together. These exponents go back to where they belong. So that's A to the 8th and then B to the 2nd. 8 log base 3 of 12 plus 2 log base 3 of 5. It's addition, so that means this is going to be a product. And it'll be the product of 12 and 5. But the exponents must go back. So it's 12 to the 8th and then 5 to the 2nd. And these are all together. Technically, you could do 12 to the 8th and then multiply it by 5 to the 2nd, but there's really no purpose for that because that's going to give you a large number that's difficult to manage. This is plus, so it's going to be multiplication, but remember that when you have a fraction like we have on the right, if you divide by 2, that's the same thing as multiplying by a half. So now we can make the multiplication part. We have log base 5, and we're going to have a z and an x. The z has a power of 2, and the x has a power of 1/2. Now whenever I have a power of 1/2, I can write that as a root. Something to the half power is a square root. So log base 5 of z squared multiplied by the square root of x. If you stopped right here, I'll give that to you. If you put this, I'll give that to you as well. If you want to go back and condense this, you can take them 2 at a time, like here and here. If I do that, then I end up with a division problem, and it's log base 2 of x over y. And then you still have this minus log base 2 of w. So if I take that next minus sign as another division problem, then I end up with this. We'll go down here, and it ends up being this. You have log base 2 of x over y, and then it becomes over w, like that, because we have this last minus sign. So if I put x over y over w, notice that the second fraction bar is longer. That means the entire fraction has a numerator that's a fraction and a denominator that's just a variable. But when I multiply, or I should say when I divide, something like x over y by w, that's the same thing as multiplying by 1 over w. When I divide by something, it's the same as multiplying by 1 over that something. So when I combine these together, I come up with log base 2 of x over yw, or wy, whichever order you put it in. This one is going to be a division, and this will go back to where it belongs, and so will this. So you have log base 2 of u to the 6th over v to the 24th. For this bonus problem, remember you can do these front two first and come up with log of x squared over y to the 3rd. And then you can tackle this thing out back here if I can write it the right way. There we go. So this is going to be yet again another division problem. So you're going to have log of x squared over y to the third, and then all of that over z to the fourth. But of course, when I'm dividing by something like z to the fourth, that's the same thing as multiplying by 1 over z to the fourth. So log of x squared, and then over top of y to the third z to the fourth is your final answer. The practice problem should end up being log 8 to the over 11 to the 30th. Start with the first two here, and you can make that log base 2 of a to the third and then b to the second. Of course, you still have this stuff back here. That's going to be log base 2 of c, and then plus 7 log base 2 of d. Now, the next two in line are these. It's subtraction. So we're going to have log base 2 of a to the third, b to the second, and then put that over c to the fifth. And we still have plus 7 log base 2 of d. Now this one's going to be multiplication, and when you multiply a fraction by something that's not a fraction, you're multiplying the numerator times that something. So we end up with log base 2 of a to the third, b to the second, and then d to the seventh. All of that would be over c to the fifth. If you ended up with two items on the bottom, then what you have done is you have inserted parentheses here and performed those two before anything else in reality, whether you actually did on paper or not. But that's what happened. Remember, we're going to go like this. Whoops, go back. Go like that, and then you include this one, and then you include that one. If I have log base 2 of 32 to the second power plus, let's see, log base 2 of 16 to the fourth power, it would indeed be log base 2 of 32, written poorly. I guess I can mark it out with white. There we go. 32 squared times 16 to the fourth. But look what happens. That's the same thing as saying 2 to some power equals this. And if you put in 32 to the second and multiply it by 16 to the fourth, you'll come back with this. And it will be 671,088,64. And we know from before, to solve that, you would have to do log of 671,088,64 divided by log 2. If you do that on your calculator, you will come back with 26. On the bonus, we can do this and this first to come up with log of x squared divided by y to the third. And then we have plus 5 log z. Well, if you have plus, it's going to be multiplication. So that means we end up with log of x squared over y to the third, and then this is multiplied against that fraction. Now, if you put it out to the right here, technically it would be right. Of course, that's a red laser pointer, so that's not going to work. If you put it out here, dot z to the fifth, it would still work, but where it should go is right here.